Hi everyone, it's Danielle from Mastering Mathematics, and in today's video we're going to be applying trigonometric ratios to find for the missing length in a triangle. Today's question is taken from the May-June 2021 Paper 2, Question 3. It's modified a little bit so that we can focus on a specific trigonometric ratio. Now, if you were looking at the last video and you saw the question at the end of the video and decided to attempt it, I hope you got the correct answer. If not, I'm here to guide you through the solution. For those of us who attempted the question and you managed to get the correct answer, great job! Let's go through the solution and let's see if you did the exact same thing. In our question, we want to find the length of PQ and we want to write the correct answer to three significant figures. In our diagram, we can see that the length PQ is next to the angle that we're given, and we're given the length of the hypotenuse. If we're given this information, it indicates to us that we need to use the trigonometric ratio of cosine. So let's apply the cosine ratio, stating the cosine ratio, cos theta is equal to the adjacent over the hypotenuse. Now let's replace it with the notation. From our question, theta is the angle formed between R, P, Q. Once we have the notation down, why don't we substitute our values? We'll replace the angle's magnitude where we have R, P, Q. This gives us cos 62 degrees. This is equal to PQ because we still need to find PQ. We don't know the length of it as yet. Over the length of our hypotenuse, 11 centimeters. Okay, we want to get the length PQ. What we need to do here is transpose. That's right. So if we have to transpose this statement, it indicates that we need to multiply both sides by 11. And what that does now is get rid of that denominator on the right hand side. Now remember, we multiply both sides of the equation. So on the left hand side, you should have 11 times cos 62 degrees, and this is equal to PQ. All we have to do is evaluate the numerical statement. And if we evaluate this on our calculator, we could do it one of two ways. We're still going to get similar answers. Alright, this is something you'll notice. If you choose to do an approximation before you get your final answer, you'll get a bit of an adjusted value. So it may be a bit larger, but nothing too significantly deviating from the actual value. If I were to do it this way, this is the value I'd get. But when we talk about doing exams, we definitely want to save some time. So why not just put the entire statement into the calculator? Let's take a look at how we do this. When we plug in this information to our calculator, make sure to use parentheses. It helps with keeping your numerical statements in order, and it indicates to the calculator as well which operations need to be performed in preference to others. Let's enter the numerical statement into our calculator. We'll begin by typing 11, our operation of multiplication, open parentheses, and enter our trig function. In this case, cosine. And now I'm going to enter the magnitude of my angle. So I type 62, close parentheses, and just simply press equal, and I'll get my value. So we write this in exact value, and then we're going to approximate it to three significant figures, and we'll have a final answer which works out to be 5.16. This is how we use our trigonometric ratio of cosine to find for the missing length PQ here. If you understood how to do this process, great job. Alright, you can look forward to one more video on trigonometric ratios to find missing sides. If you found this video helpful, be sure to like, subscribe, and let us know how have you been managing with topics we've been sharing with you so